right, find the curvature of r of t equals t squared ln t ln t at the point 1, 0, 0. So we know the formula for our curvature. There's two of them, but the one that we're going to use for this problem is going to be k equals the magnitude of r prime of t cross r double prime of t divided by the magnitude of r prime of t cubed. So this is a really scary vector, but luckily for us, we know that it's at the point 1, 0, 0. So therefore, at that point, since t squared is equal to 1, and ln of t is equal to 0, and the t ln of t is equal to 0, we know that t is equal to 1, because the ln of 1 is 0, 1 is 0 times that, you know what I'm saying? All right, so I'm going to get this out of the way. We know that r of t equals the vector t squared ln t ln t. So the first thing that we're going to do is take the derivative of it. So r prime of t is equal to, pretty easy, 2t. And then ln of t is going to be t to the negative 1. And then t times the ln of t. So the ln of t is going to be, so we're going to have to use product rule for this one. So the derivative of t times ln is going to be ln of t. And then the derivative of ln of t times t, add that, is going to be t over t, which just equals 1. So this part is going to be ln of t plus 1. Now we need to find the magnitude, which is going to be the square root of 2t squared plus t to the negative 1 squared plus ln of t plus 1 squared. But we know that t is equal to 1, so we're just going to plug t into all these values and put it in our calculator, and that's going to give you the square root of 6. So that's our magnitude. So put that magnitude right there. So things are going pretty well so far. So now we need to find the second derivative. It's going to be r double prime of t, and that's just going to be equal to, we got t already, 2t rather, t's going to go away, and we're going to have 2. And then t to the negative 1, we're going to bring that negative 1 down and get negative t, and that's going to be squared to the negative 2 rather. And then ln of t, that 1's going to go away. It's going to be 1 over t, which we're just going to call that t to the negative 1. That seems to be the theme now. So r prime of t, we've got to get our top value. It's going to be r prime of t cross r double prime of t. So r prime of t cross r double prime of t is going to be equal to, set up our cross product, I, j, k of 2t, t to the negative 1, ln of t plus 1, and then 2, negative t to the negative 2, and t to the negative 1. So plus minus plus. For our I value, we are going to get t to the negative 1 squared, so t to the negative 2 minus ln of t plus 1 times negative t to the negative 2, so plus t to the negative 2 ln of t plus t to the negative 2. That's going to be in the I direction, minus the vector for j, 2t times t to the negative 1. We are going to get, the t's are going to cancel out, so we're just going to get 2 minus 2 times the ln of t plus 1, so ln of t minus 2j, and then we're going to get negative 2t to the negative 1 minus 2t to the negative 1 in the k direction. So when we simplify that out, we can take the t's out of this one and get t squared times ln of t plus 2, and then 2, we got a -2 and a +2. Those are going to cancel. And then this negative is affecting that. So it's just going to be positive 2 ln of t. And then this one's pretty easy, just -4t to the -1. All right, now that we have our r prime of t cross our r double prime of t, we got to get the magnitude of it. So r prime of t cross r double prime of t equals the square root of, it's going to be a big one. We're just going to plug in our values for t at this point because we're going to have to do it anyway. So our value for t is 1, so t squared is going to be 1. I believe that's actually supposed to be to the -2. Yeah, t to the -2. Yeah, to the -2 times the ln of 1 plus 2 squared plus 2 ln of 1 squared plus -4, 1 to the -1 squared. And when you solve that, you get the square root of 20, which is equivalent to 2 square roots of 5. So we have pretty much all the hard parts done. We now know that kt is going to be equal to 2 square roots of 5, our value for the magnitude of the cross product, divided by the square root of 6, which is our value for the magnitude of r prime of t, and that whole value on the bottom is cubed. And with that, we get 2 square roots of 5 over 6 square roots of 6. Obviously, 6 times 6 is going to get rid of the square. And then you multiply it again. You can put that square root back. And that is equal to just about 0.3043.